Now we're going to go over Blender's new user interface, and we're also going to customize it to better work with environments. And a lot of this is personal preference, so you don't have to follow it exactly. First thing I'm going to do is get rid of this ugly 3D manipulator by disabling it in the 3D header. And now we're going to learn how to split and join windows. To split a window is pretty simple. There are these diagonal lines in the top right corner of each window and in the bottom left corner of each window. If you left click and drag to the left, you can split it. You can also drag it up or down to split it horizontally. And to join them, simply left click on it and drag it up or over to the next window. If you hold shift and left click on those diagonal lines and drag it, it'll actually make that window pop out into its own window. And if you hold control and left click on one of those lines and drag it to another window, it'll actually swap the two. So right now what I'm going to do is I'm going to join the 3D view with the timeline, because I don't need the timeline. And these windows on the right here, I'm going to join those together so that we just have two windows right now, 3D view on the left and all of our options on the right. I'm going to swap these by holding the control key, left clicking on the diagonal lines, swapping it over. So now we have all of our buttons on the left side and our 3D view on the right. I'm going to split the 3D view and we'll load the image editor on the right side. For the 3D view, I like the header to be at the top, so I'm going to right click on a blank area of the header and choose flip to top. Now this tool shelf on the left here is an interesting thing. There's operators at the bottom here, which, for example, if I were to add a mesh circle, that's where the prompt is to tell Blender how many vertices you want it to have and how big you want it to be. It's kind of annoying, but that's the way it is at the moment. Hopefully they change that back to getting a prompt pop up, because most of the time I have the tool shelf disabled and I hate having to go in there and change the vertices by hand. The T key, by the way, is the hotkey to display the toolbar and to hide it. You can also use the plus sign at the top left of the 3D view. Now, the most important thing in the toolbar here is the shading panel for set smooth and set solid. That's where these options are found now. So if we hide that real quick, there's also a plus sign at the top right, which has a lot of other options. So I'm going to enable that to display all the options. And under the view panel, actually not the view panel, under the display panel, when I rotate the view, one thing that I really hate is when the grid gets in my way. So I'm going to disable grid floor, X, and Y. It only disables them in a rotated view. When you're in top view and side view, everything's still the same. But when you go into perspective view, the grid will be hidden. Another thing we're going to change is shading from multi-texture to GLSL. So that when we go into textured view, all of the lights will affect our objects, and all of the materials and textures of the objects will be displayed as well. Let me show you, for example, by taking this cube. It already has a material. We can play with the intensity. We can crank the intensity up to 1 of the diffuse. And I'm going to add a quick texture to it. Let's see, I'm going to change the texture type to image. I'm just going to quickly open up one of the textures from the project, the barrel texture. Now you can see the barrel texture is applied to the cube. And this is real time, so if we move the lights, everything is going to update. And if you press the P key, it should look exactly the same. It does. And if you render it, it'll look exactly the same as well. That is a huge bonus of GLSL in Blender, is that you can preview in real time in the 3D view exactly what you're going to see in the render and exactly what you're going to see in the game engine. Of course, there's limitations to all the things that can be displayed by GLSL in the 3D view. Like, I think there's a lot of limitations when it comes to nodes, but a lot of nodes actually work in 3D view as well with GLSL. Now, for GLSL shading to work on your computer, you need a graphics card that supports it. I know a lot of ATI cards and GeForce cards from NVIDIA support GLSL. I'm not sure exactly which models. But if you don't have a computer that supports it, or a graphics card that supports it, you can simply just preview your objects by pressing the render key. So now we got that set up. going to delete that circle I created. And we're going to go back to customizing user interface. I'm going to hide this window on the right there. I'm going to delete the default cube. We don't really need anything in the scene to create our base scene. Our base layout. Now go up into the File menu, select User Preferences. We're going to change some preferences now. In the Interface tab, one thing I'm going to do is turn off Smooth View. Let me show you what that does real quick. If I were to go into Side View, and then Front View, and then Top View, you'll see how everything rotates, kind of like an animation. We change Smooth View down to 0. Everything is now instantaneous, which is how we want it. This this isn't going to be like for a client presentation or something. We don't need it to be all fancy. When I want to go into Side View, I don't want it to take 3 seconds to get to Side View. Another thing we want to enable is Auto Depth and Zoom to Mouse Position. Zoom to Mouse Position is pretty obvious. Wherever your mouse is on the screen, it'll zoom into it when you start zooming. Auto Depth is good for rotating the scene. So if I were to add a cube up there, I would rotate the scene by middle clicking in a blank space. It's going to rotate it around the world origin or the world center or whatever. However, if I were to middle click on the cube, you can see now that now it is rotating around the point of the cube that I clicked on. If I move the cube down here and I middle click on it to rotate the scene, it's going to continue to rotate around the point that I click on. This is incredibly handy when you're working with environments and lots of different objects, because instead of having to pan the scene to get the center point of the rotation correct, you simply have to click wherever you want to rotate around, and that'll work. So back in the user preferences, we're finished with this panel. Let's go over to the editing tab, and I'm just going to change Align Object to View, so that the axis is aligned to the view that I'm currently in. Otherwise, if you keep it at world, no matter what view you're in, the object will always be added with the z-axis pointing up. And that's all we need to change in there. In the Input tab, we want to enable Emulate 3-button mouse, just because I like using the Alt, Control, and Shift keys when I'm rotating, zooming, or panning the scene. That's just a personal style preference. That's what I've been using for like 10 years. Zoom style. This is incredibly important for environments. Change dolly to continue zoom. If you have dolly zoom, you cannot zoom past and through walls. So when you're working with an environment, you want to be able to do that. So choosing continue zoom allows you to continuously zoom, as you can see. And when you're in perspective view, I'll be able to zoom right through this face to the inside of the cube. You cannot do that with any other zoom, not easily anyway. This I can just continue zooming, no matter how far. So when you're working with an environment, there are going to be lots of obstacles that get in your way when you use zoom. You want to be able to just bypass them. You don't want Blender to take into account that you're zooming into a specific face. If I want to stop zooming at that face, I'll stop zooming at that face manually. So that's why I enable continue zoom. I cannot work without continue zoom, especially with environments. It's just too frustrating. So we're done with the Input tab. Nothing important in add-ons. I think everything else looks good. So that's it for the user preferences. You can simply select Save as Default now, and it will save that as the default blend file. Let's get rid of these XX cubes though. Or you can press Control and U to save user settings. And that's it for the interface. While working in edit mode, there's a few cool tools you need to know how to use. Loop cuts and knife cuts. We'll start off by making some loop cuts in this cube here. But first I'm going to apply a subsurf modifier to it. Subdivision surface. And a subsurface cube looks pretty much like a sphere. Now what we want to achieve here, if you go in edit mode, is we want to add loop cuts around all of the edges so that we have a beveled cube instead of a sphere. To do that, you can press the Control and R hotkey, and these purple lines will show up. They're guides that tell you where the loop cut is going to be created. So if you left click to accept one of these lines, let's make a vertical line first, you'll get a new edge loop. Now you can slide this edge to the left or to the right, all the way to the bounds of whatever the mesh is. So let's slide one all the way to the left. Let's press Control plus R again, create a new one and slide it to the right. And you'll see now we have a bit of a beveled cylinder. So back in side view, let's add a couple horizontal cuts by pressing Control plus R. And if we go in front view, we just need to add 2 more to finish off this bevel. And there's our beveled sphere. When using subdivision surfaces, the closer the edges are together, the more of a bevel you'll get, the more of a controlled bevel you'll get. The further they are apart, the more of a smooth transition you'll have. So when you keep edges packed closely together like this, you'll get a nice tight bevel. And one thing to note as well is that Set Smooth and Set Solid has changed its position in Blender's user interface. We're now in the tool shelf on the left of the 3D view, under the shading panel here. Set Smooth and Set Solid. To access the tool panel, you can press the T key, or you can use the plus sign up here in the top left of the 3D view. And now let's learn how to use knife cuts. Now, knife cuts are for when you don't want a perfect edge loop, or if you just want to split a single edge or a few edges in a way that you define. So with all the vertices selected, if you press and hold the K key, which is the knife tool hotkey, you can just left click and drag across a few edges and it splits them for you, or it cuts them for you and adds new edges and new vertices. I use this tool all the time when we're destroying the environment. After I lay down a bunch of base shapes for pillars and planks and things like that, I go through and I just add a bunch of knife cuts to it, and I bend things out of shape to make everything look like it's dilapidated and worn down. So that's how loop cuts and knife cuts work. One issue I encountered while working on the project is that I was unaware that the edge split modifier actually worked in the game engine, that it was compatible with the game engine. So I end up splitting all of the edges manually so that I can use the Set Smooth tool. Now let me show you what I mean real quick and how to use that modifier. I'm going to select the cube. I'm just going to make a few extrusions. So now I have an object that has a few acute angles that I would like to smooth out, but also a lot of 90-degree angles, which I want to make sure are solid. Now if I were to go into the toolbar on the left and just simply press Smooth, you can see all the artifacts created by smoothing out those 90-degree angles. Now what I've been doing for pretty much as long as I've been using Blender is splitting edges manually by going into a certain view and selecting one side of the object and pressing the Y key. Y key splits those faces away from the object but keeps them in place. So you can see now that the 90-degree angles are no longer smoothed, but all of the acute angles are. So what I do throughout the project is I split these faces manually by just using the Y key. And in a second I'm going to show you how to use the edge split modifier to automate this process. Now the edge split modifier essentially does the same exact thing that I just showed you here, except that the whole process is automatic and it makes for much cleaner meshes in the end. So let me just select all of these vertices, press the W key, and remove the doubles. So now we're back to our original artifacty, smooth 90-degree angle object. I'm going to get rid of the toolbar because we won't need that. And in the modifier buttons, I'm going to add a modifier called Edge Split. Now you can see that it smoothed most of the small edges, but we can change the angle at which things start to smooth. Right now the split angle is at 30 degrees. We crank that up to 60. Now the edges on the side will be smoothed as well. So all of the angles that we want smoothed are smoothed, and all of the sharp 90-degree angles, they remain solid. and we didn't have to manually split any of those faces. You can apply this if you want, and you'll essentially end up with the same mesh that we just created manually, or you can leave it there and it gets applied when you press the P button to enter into the game engine. So this modifier is actually compatible with the game engine, and throughout the project when I start splitting edges manually, I'll remind you to use the edge split modifier instead. And we're going to learn how to make linked duplicate objects single users. Now what a linked duplicate object is if you select this cube here and press Alt plus D, which is link duplication, you'll see that if you enter edit mode, that when you edit one, all of the link duplicates are edited as well. So if I were to press Alt D a few more times, then go into edit mode and edit one, every one of them will change. Now obviously this is useful for a lot of different reasons. With all the mesh data connected, if you have lots of the same objects in a single scene, and you need to make one change to all of them, you'll simply only need to change one of them. But sometimes when you're finished placing objects around a scene, you want to be able to edit one and just one. You want to be able to create a single user out of that one object and edit it for whatever reason. To do that, you can select whatever object you want to make a single user, go up into the object menu, scroll down to make single user, and select object and obdata. Selected objects. Now you can go into edit mode and you can edit this as its own unique individual object. I'm going to delete those. We're back with one cube, and now I'm going to show you the usefulness of the 3D cursor. Now normally when you scale things and rotate things, it'll rotate around that object's center point, its pivot point, its origin. And when you select two objects, it'll get the median between those two pivot points, and it'll scale and rotate between them. Now say we wanted to scale or rotate something along the 3D cursor around the point of origin that we choose. Then you can simply place the cursor anywhere, go up into this menu here, where the default is bounding box center, and select 3D cursor. Now if you press the R key, you'll see that you're now rotating around the 3D cursor. And it works with sizing as well. So I use this all throughout the project as well, because sometimes I want to, say, create one wall, and I want to rotate I want to duplicate and rotate that wall to the other side. So I center the cursor in the environment, I duplicate it, and then I rotate it or scale it to -1 onto the other side, and it will flip everything perfectly for me. Now we're going to learn how to bake normal maps using the option selected to active. What that means is we're going to create a high poly cube with a nice bevel, and we're going to bake that normal map onto this low poly cube here. So first we're going to duplicate this cube because we need two of them, but keep it in position. Press the M key to move it to layer 2. Now select the cube in layer 1, and we're going to give this a quick bevel by going into the modifier buttons and add a bevel modifier. And click on this copy button here to add a second bevel modifier, and yet again to add a third, just to get some quick detail there. Now press smooth in the shading panel in the toolbar on the side of the 3D view. And now the bevel modifiers don't work that great. You can see some artifacts in the center there, but it doesn't really matter because this is just a quick example of how to bake a normal map. I'm going to apply all these modifiers just because I don't like looking at them, but I don't really think it matters. You can probably bake with the modifiers turned on since baking is essentially rendering. So hold shift and enable the second layer. And right now what we're going to do is split the window. And on the right side we're going to load the UV image editor. We're going to take this cube here, and we're going to press Ctrl and E and mark as a seam all of the edges selected. And press U, select Unwrap. So now we have 6 faces. Now if this is the only object you're using for this texture map, I would suggest stretching it out like this Only for the normal map though, because you can increase the amount of detail in your normal map by using all the texture space in your UV layout. But don't do that for a color map. If you're using a color map as well, or using the same UV layer for a color map, keep everything square. But just because we have some empty space, I'm going to stretch it out like that so we can utilize it. So I now have the low poly cube unwrapped. By the way, I made sure I hit set smooth on the high poly cube. So first, select the high poly cube, hold shift, and select the low poly cube. And now in the render buttons, scroll to wherever the bake panel is and expand it. Enable selected to active. Now the dark orange is the selected cube, the one that we selected first, which is the high poly cube. The active selection is the one that's lighter orange, which is the second cube that we selected, the low poly cube. So I'm going to select bake mode, normals, and normal space tangent. That's what we're using all throughout this video. Tangent is pretty much the default for all normal maps and the most commonly used. And everything else looks fine, so let's bake that and see what happens. It says no images found to bake to up in the top here, the error. That is because we did not apply an image to our low poly cube that was unwrapped. So let's go and let's add a new image. I don't know what size that was. Let's check. 1024 by 1024. Doesn't really matter what size. This is just an example. So now that that has an image applied to it, we'll go back and select the high poly cube, hold shift, select the low poly cube, make sure selected to active is enabled, and then press bake. You can see that the bevels were now baked into a normal map for the low poly object. And now, with just layer 2 enabled, which is the low poly cube, we're going to create a texture so that we can visualize this normal map. But one thing you got to make sure to do is in the image window, make sure you go into the image menu and press save as and save that image somewhere, else you're going to lose all that data if you close Blender. It will not prompt you to save that image when you close Blender. You will lose all that data. So with that low poly cube selected, let's add a new material for it called normal. Doesn't really matter. And in the texture buttons, add a new texture, image type, and from the library load in the normal map you just baked. In the mapping panel under coordinates, select UV. And in the image sampling panel, enable normal map, change the type from camera to tangent. And under the influence panel, deselect color since this is not a color map, and enable normal under geometry. And let's get some lights in this layer. I'm going to add a quick lamp to this layer, a point lamp. Press Alt plus Z, or go up into this menu here and select textured. Make sure that in your view properties, which is the panel on the right of the 3D view here, if you'll scroll down to the display buttons, the display panel, make sure that shading is enabled to GLSO. That way we can preview this normal map on our object. The bevel does not look great applied to this cube, but to illustrate the point of baking normal maps, it worked just fine. If you want this cube to look good, what you could actually do is select it and scale each of these faces down. We'll have to scale them down one by one. If you scale them down so that they're closer to the edge, everything should end up looking better. Scale them down a little bit just to act as sort of a margin. So I scaled those 3 faces down, and now you can see the bevel standing out a lot more. I'm not going to worry about the other faces. This was just to illustrate baking normal maps using selected to active. Now we're going to learn how to bake AO maps, ambient occlusion maps, and how to use multiple UV layers to do it. We're going to make a simple scene. I'm just going to create a new plane from top view for this cube to sit on. Oh, there's our scene. I'm going to join both of these meshes together to make this easier on me. Now the first thing we're going to do is UV unwrap these. We're going to texture them real quick with one UV layer, and then we're going to create a new UV layer to bake an ambient occlusion map to. So I'm going to split the window. On the right side I'm going to change it to the UV image editor. I'm going to load in a simple texture. I'm going to take the palette color texture. I'm going to select all the faces and press U, and I'm going to use Smart Project just to get a fast unwrap. I'm going to apply the palette image to those UVs, and now we're going to set up the texture for this really quick. So in the material settings, it should already have a default material. If it doesn't, add one. I'm going to crank diffuse intensity up to 1. And now in the texture buttons, add a new texture. Change the type to image. Call this layer texture layer color. Under mapping, change the coordinates to UV. And under layer, right now the default UV layer is called UV text. Let's go change that real quick. We can change that name in the object data buttons, which is the little triangle icon. Under the UV texture panel, there's our one UV layer that we have so far. We're just going to simply rename that color. So this is going to be the UV layout for our color maps. So back in the textures, make sure you change layer to color, and everything else should be fine. Now let's load in the palette image, and there's our scene so far. Now I'm going to take these UVs, because the wood's not showing up as small as it should. I'm just going to take these UVs and I'm going to scale them up. I'm going to take the UVs from the cube. I'm just going to be real specific with it. So those are how our UVs are set up now. Now with the UV layout like this, we can't just simply bake an AO map to this, because you can see that the plane here is pretty much overlapping everything else. So if we were to bake an AO map, it would go outside the bounds and kind of overlap itself within the UV space. It would just be no good. So that's where multiple UV layers comes in handy. So now we have our tiling color map. Let's create a new UV layer. Now if you are in edit mode, when you press this plus sign in the UV texture panel to create a new UV layer, it will reset all of your UVs when it creates that new layer. And it will reset them for the new layer. But don't worry, your UV layout for your color layer, all those UVs will still be intact. So for example, if I press the plus sign, all of the UVs reset in the new layer. But if you highlight the color layer again, you'll see all your UVs are still intact for that layer. I'm going to erase that UV text layer, the new one we just created. And I'm going to get out of edit mode, and just in object mode, if you create a new UV layer and go into edit mode, you'll see that it maintained those UVs in the new UV layer now. So now both UV layers have the same UV layout. So with UV text layer enabled, let's rename that to AO. And I'm going to rearrange these UVs now by first creating a new image. 1024 by 1024 is fine. And now we want to use every pixel of space possible in here. So we can either rearrange these by hand, or we can just select all the UVs again and re-unwrap them using Smart Project. That looks good. So now we have our new UV layer with our new UVs applied to a new image. Now all we have to do is simply bake ambient occlusion to it by going into the render buttons. And there's a panel at the bottom called Bake. Let's expand that. Let's change bake mode to ambient occlusion and leave everything else the same, except let's enable normalized. Now with normalized enabled, we'll have an ambient occlusion output that will have a lot of contrast. All of the colors will be rendered from true white to true black, and that's what we want. So just press bake real quick. When you move the image while it's baking, it'll update for you. So our ambient occlusion map has just been baked. And now all we have to do is simply apply this to our texture stack. First thing you want to do is go into the image menu and save that image somewhere. I'm just going to save it as ao.png. And go back to the texture settings. Go into a new texture channel. Create a new texture called AO. Change it to type image. Load that new AO image in. Change the coordinates to UV. And change the layer to AO. And down at the bottom, change blend mode to multiply so that it mixes with the color map beneath it. And just so we can get a better idea of how this looks, I'm going to change the sunlight settings. I'm going to change it to a sun. That's kind of a weak scene to be baking an AO map to, but you get the idea. That's how baking AO maps works, and that's how using multiple UV layers works. One thing you want to make sure is that when you are finished creating new UV layers, is to go back to the mesh options, or the object data options, and highlight the color layer as your enabled layer. So all you have to do is click on color, UV layer, for that to be enabled, because if any other layer is enabled, things like normal maps aren't going to appear correctly. And I have this problem when I'm working on the project as well. But in the last chapter, when I do final fixes, I notice that the normal maps aren't appearing as correctly as they should be. So I end up having to go through and select all the objects and make sure that the color UV layer is enabled. So it's a simple thing and a simple thing to remember. Always have your color UV layer enabled. And that's it. One thing, make sure that you save your AO images when you bake them, or any image that you create in Blender. Make sure you save that, because if you close Blender, it will be erased. Now we're going to learn how to splat multiple textures onto a terrain using multiple UV layers and a stencil map. First, we're going to create the terrain real quick. I'm going to add a plane from top view, and I'm going to scale it up and subdivide it a few times. Then, using proportional vertex editing, I'm going to create a few hills so that we can have a valley in between them to paint a nice dirt pathway. I'm going to bring the toolbar back. I'm going to press Set Smooth. And now we're going to split the window, and on the right side load in UV image window. I'm going to select all the vertices and press U and select Unwrap. Now we're going to load a grass texture in for this. I'm going to load in ground grass cowl from the textures folder. Now because I want this grass texture to be tiling, I'm going to scale those UVs up quite a bit. Now they're not displaying yet because we have to create a material for it. But first, in the object data buttons, which is this little triangle icon, there's a panel called UV texture. And there's a UV layer called UV text, which is by default. We're going to change the name of that to color. Essentially saying that this UV layout here is going to be used for all of our color textures, but also like our specular maps and our normal maps, things like that. I just call the UV layer color because it's very clear to me. So now we're going to create a material for this object. Create a new material called ground, and turn the intensity of the diffuse up to 1, specularity down to 0. Create a new texture now. Change the type to image. I'm going to rename that grass. We're going to load in the grass image. And it's not applied to the plane quite right. It's because we have to change the coordinates under the mapping panel to UV and change the layer to color. Everything else stays the same. I'm going to select the light real quick, and I'm going to change it to a sunlight so I can see what I'm doing. Now, back on the terrain, back in the textures, select the third texture slot down. We're going to create a new texture, change the type to image. We're going to rename this to dirt, and we're going to simply load in a dirt texture for our dirt pathway. Do the same thing that you did with the grass, change coordinates to UV, change the layer to color. You can see our terrain is now completely dirt. Now we're going to create a stencil map to put between these two texture maps, and that's going to tell where the dirt to display on top of the grass. And it's pretty easy. First thing we have to do is create a new UV layer for the terrain and then create a new image for our stencil map. So back in the object data buttons, click on this little plus sign icon in the UV texture panel, and it's going to create a new UV layer, which we're now going to name stencil. And we're going to create a new image while in edit mode with everything selected at 1024 by 1024, color black. And we're going to press U and select unwrap to re-unwrap the terrain to fit within the UV space. We're going to save this image as stencil.png. And now in the texture buttons, in the middle texture slot there, between the grass and the dirt, create a new texture, call it stencil, and change the type to image. And then load in the stencil map. Change the coordinates to UV, change the layer to stencil, that's important. Disable color since it's not a color map, we're just using this for the grayscale values. Enable RGB to intensity and enable stencil. Now if you update the scene by just rotating it, GLSL will now display the texture stack using the stencil map. Because the stencil map is all black, our terrain shows up as all grass right now. And to better illustrate this, we'll start painting on the texture map by painting on the terrain. We're going to paint our our dirt pathways now. So simply change object mode to texture paint mode. But first make sure that in the object data buttons that your stencil UV layer is enabled and that all of your UVs are applied to your stencil image, because that's what we'll be painting over in texture paint mode. So now change object mode to texture paint. Bring the toolbar back on the left. And now if you paint white, you'll have a dirt pathway, and if you use black, you'll have a grass pathway. And as we're painting, keep your eye on the texture map on the right, the stencil.png image. It's going to update as we're painting. So I've got a white brush now at strength 1, and I'm just going to go through, I'm going to paint the dirt pathway between these hills. You can see the stencil image on the right is now updating as I paint. If you paint a little bit too much dirt, just change the color of the brush to black. You can paint grass on there now. You can use any value in between black and white, or you can just simply change the strength down to maybe 0.3 and kind of mix the dirt with the grass to get rid of all that tiling look. And there's our quick terrain. We'll go back in object mode, see how it looks. So now if you take a look at the stencil image on the right, you'll notice that it's really only the white area that matters that much. Anything in the black area is not going to be used to display anything. It's the white and grayscale values that determine where the textures are displayed, where the dirt textures are displayed on top of the grass. And it's as simple as that. Now if you wanted to add specular maps and normal maps, you would just create new texture slots above and below the stencil map texture. One thing you want to make sure you do is in the image menu, make sure you save this image. Because if you don't save the changes that you make to that image, Blender is not going to save it for you, and if you close Blender, you're going to lose all that data. Now I'm going to show you a few different tools in Photoshop. First, I'm going to open up a photograph that we can manipulate. So if you go to the TextLib folder, and then Vehicle Tires folder, open up Truck Tire 1. It doesn't really matter what image you open up, I'm just looking for something with contrast. I'm going to show you a few selection tools first. First thing we want to do is enable transparency for this image, which we can have with a background layer that's locked, which is usually the default. So if you just double click on that background layer and press OK for that new layer, now we can have transparency. So I'm just going to make a quick selection and delete part of that image. I'm going to unload that selection so that nothing is selected right now. Now if I wanted to select the outline of this image, if I wanted to select the outline of this entire layer, I can simply hold the Control key and left click on the image on the layer, and it will select that entire layer. And this selection also works if there were transparent parts of the image. Like if I were to take the eraser brush at 50% and erase the edge of that layer, hold Control, left click on the image in the layer, and it will actually make a transparent selection around that edge. So if I were to hide that layer and add a new layer and use the paint bucket tool with red, I just filled within that selection, and now you can see that the edges are indeed transparent. So that's a selection tool that I use a lot. I'm going to undo all of that. Now I'm going to show you a different selection tool. If you go to the Channels tab and check out this circle icon at the bottom, which says Load Channel as Selection, what this does is selects parts of the image based on their grayscale values, basically, if you have all of these channels enabled. So if I click on that, it's going to select all the light parts of the image, and it also includes transparent values depending on how dark part of the image is. So if I were to switch back to the Layers tab now and press the Delete key, you'll see that based on its grayscale value, or based on its intensity value actually, based on how light a part of the image is, it was either deleted or made more transparent. You can see that the darker parts of the image are much more opaque, and that the white parts of the image, like the side of the truck and the area underneath the truck, they're completely transparent. They've been deleted almost entirely. Might be like 1 or 2% opacity in areas like this. Otherwise, they're gone. And this is very useful in case you're creating a real grungy texture and you just want to pull some details from one photo on top of another without using something like just a blending mode. So you can use that selection tool, which is in the Channels tab. Just press that circle icon and it'll select all the light parts of the image. Then you can press delete and it'll get rid of those light parts, or you can have that selection go up into the select menu and inverse that selection, and then it'll delete all the darker parts of the image. Well, now we have nothing, but you see how that works, and I use that throughout the tutorial as well when I'm creating textures. Now to use the NVIDIA Photoshop filter, just with any layer selected, you can go into the filter menu, scroll down to NVIDIA Tools, and select Normal Map Filter. But first, the trick I use to create a decent converted normal map is to duplicate the layer and create 2 different conversions for these layers and then mix them together. One conversion is going to be for bumpiness, which is going to be a bit of a blurred layer, and the other is going to be for very sharp and fine details. So for the top layer, we're going to convert it to a sharp normal map. So go down to the NVIDIA Tools, select Normal Map Filter, and select either 4 sample or 3 by 3. We'll go with 4, that's usually good. At scale 10 and height source average RGB. The bigger the sample size, the more blurry the normal map details are going to be. So I'm going to stick with 4 to begin with. You can see all of the details are coming through nice and sharp. I'm going to hide that layer and select the layer beneath it, the duplicate layer, and go back into the normal map filter. I'm going to change the sample to 9 by 9. at scale 10. I'm going to press OK, and you can see this is a lot more blurry. Well, it's not exactly blurry, but it's bumping out a lot more, and that's going to make it really stand out in Blender. But what it's missing is all of the sharp details. So if you enable the top layer, you can see the difference. So for the top layer, we're going to mix this down with the bottom one by either selecting Overlay or Soft Light. They both work well, it's just a matter of personal taste. I'm going to select Overlay, and now you can see the two layers are blended together pretty damn good. We have not only bumpiness from the blurred normal map conversion, but all the sharp details from the 4-sample normal map conversion. And if you don't want that many sharp details, you can also play with the fill opacity, or the fill percent, or opacity percent, doesn't matter. I usually keep the sharp detail layer down to about 50%. And that's how you would create a successful normal map, by using the normal map filter in Photoshop. But there's one other thing you have to remember. Blender works with normal maps in a bit of a unique way, I guess you could say. If you convert a color map to a normal map in Photoshop, one thing you have to do for it to work in Blender properly is select that layer with the normal map. Actually, I'm going to join those two layers together so we just have one. Select your normal map layer that you just converted, go into the Channels tab, select the red layer, and press Ctrl+I to invert those colors. The red layer has to be inverted for it to appear correctly in Blender. And that is only on normal maps that are created with the NVIDIA filter. If you bake a normal map in Blender, they're going to be baked correctly, or at least correctly relative to Blender. And there's our finished normal map. Now we're going to go over one more tool with Photoshop. This is how to paste in place. I know newer versions of Photoshop might have this ability, but Photoshop CS2, as far as I know, does not. So I'm going to create a new document at 500 by 500 and a second new document at the same exact size. So let's just say, for example, the document on the left here is our color map, and we want to copy some of the details from the color map over to our specular map, let's say this is. But we want to copy these details from the same exact position and paste it into the same position in the specular map. Let me show you an example. We're going to create a new layer on our color map. We're going to create a few details towards the bottom there. Now if I select everything and I copy that layer and I paste it to our specular map, you'll see that it centers it. What you have to do to get it to paste in place is simply give it some positions to work with. So I'm going to paint in the top left corner and the bottom right corner. I'm going to copy that again and paste it, and it pastes precisely into place. And I just go over with an eraser, erase those two corners. So it takes a couple extra seconds, but it's no big deal. Now I'm going to show you one of the snapping tools I use during the project. First, I'm going to take the default cube and create a bumpy terrain with it. I'm just going to make a few simple extrusions, giving me different levels and different angles. I'm going to create a new cube, and in side view I'm just going to extrude it up and make a pointy top to it so we can tell which direction this cube's facing in. I'm going to scale it down and set it at the bottom of the terrain. Now the goal here will be to place this cube on all the different levels of this terrain and have it rotate based on the angle of the face on which it's sitting. So to do that, first we're going to edit mode of the pointing cube, and we're going to move the origin to the base of the cube, because that's what we'll be snapping to the ground with. So the origin at the base, when we snap this cube to the ground, it's going to take into account where that origin is and seat this cube on top of the faces. So with the origin placed, we're going to go up into the header in the 3D view and enable this little magnet icon called Snap During Transform. Now right now, it's on increment, which means it's snapping to the grid. This little menu next to it, you'll see all the different types of snap. Increment means it's snapping to the grid. Vertex, edge, face, volume, all kind of self-explanatory. We're going to choose face. And there's another menu next to that called, well, the default is closest, which means it'll snap the closest part of the object to the faces underneath it. But we're going to change that to center so that it uses object origin to snap the object. So now I move the object all the way up there. You can see a little circle around the origin, telling you where it's snapping to the object. If you rotate the view, you'll see that it's snapping directly onto all of those faces. So now that we have snapping, what we need to do now is rotate the object based on the angle of the face underneath it. To do that, there's a little icon to the right of those two menus we just went in. It's a little sphere with a little, looks like a lightsaber poking out of it. Caption reads, align rotation with the snapping target. So if you enable that, now our object will rotate with the faces and also snap to the faces. So I'm going to make a few duplications of that. And we just basically made a studded belt or something. So that's one of the snapping tools that I used during the project. Comes in handy when you're placing a lot of different objects onto something. And that's that. I'm going to show you the advantage of using something called Clip Alpha. It's a new type of alpha added into Blender to fix the alpha sorting problem the old alpha had. So I'm going to show you what the problem was, and I'm going to show you how to fix it. First thing we're going to do is create an alpha image. I'm going to go to the TextLib folder, and I'm going to go to Stone Rock Walls and open up Old Stone Wall. Now, so that this image can have some transparency, we first have to unlock this background layer by double-clicking on it and then pressing OK. So select the lasso tool and just go through and make a nice little outline and delete the top part of that image. This is going to be a decal for the wall. Where the concrete around it starts to crumble away. I'm going to use an eraser brush. Just going to use a regular blurry one. I'm going to blur the edges. This is just to illustrate a point that I'm going to make. You'll see what it is. I'm going to save that image as stonewall.png, saving it as a PNG so that I can have alpha data. With that saved, in Blender, I'm going to delete the bottom part of that cube. I'm going to split the screen. Change the right side to the UV image editor. I'm going to load in that stone wall image we just created. I'm going to create a new material and texture. Change the texture type to image. I'm going to load in the stone wall image. And under the image sampling panel, I'm going to enable use under alpha. I'm not sure if that's necessary, but I do it anyway. Under the mapping panel, change coordinates to UV. And under the influence panel, enable alpha. It's not working quite yet. There's still one more thing we have to add. Under the material settings, we have to enable transparency. And if you expand that, change the alpha value down to 0. Now, if you see the outline of this image, you can see that it's starting to tile by like 1 pixel. That happens because of bitmapping. So if we just simply scale these UVs down a little tiny bit to act as a margin, you'll get rid of those. So now this alpha looks pretty good. Now the problem with regular alpha is if I duplicate this a few times, I press the P key, everything looks fine. However, if I were to reorder these and put the front one in the back and press the P key, you'll see that that's now showing up in front of the other two despite it being in the background. Now that's the alpha sorting problem that is fixed by using Clip Alpha. If you go into the Object Data buttons, which is the little triangle icon, now it's not visible at the moment, but if you go up into the top header, change Blender Render to Blender Game to get that set of buttons enabled, and go into Edit mode of this object, you'll see the texture face panel appear. That, however, will not appear in the Blender Render options. You must be in Blender Game options. So with that face selected, change the transparency type to Clip Alpha. Get out of Edit mode, and if we zoom into it, you can see that the edge is not faded out. the pixels are either visible or they are invisible, whereas the alpha in front of it, the alpha object in front of it, fades out. However, the problem with that is what we just saw, the alpha sorting. Things in the background might pop up in the foreground, which is really stupid looking in a game when like a patch of grass a mile away is appearing in front of all the walls. So that's why we use clip alpha. So if you enable clip alpha for all the faces and press the P key, they are all aligned as they should be. They're all sorted as they should be.